Okay. This lecture is for the starting students this year. A lot of you are actually getting into the next module. However, I haven't gone over everything I want to go over with this module, so I'm going to be asking you guys to maybe backtrack a little so you can actually get more out of um, this class, and I will be highlighting a lot of the information that A plus will expect you to know. I'm not trying to add any filler. I'm not trying to um, complicate things, but the things that I go over in lectures are the things that you need to be worried about for the A plus. So I'm using YouTube to fill in the gaps because we're only seeing each other 2 to 3 times a week instead of 5 times a week. So there still will be live lectures, but I'm hoping that I can actually disseminate more information to you guys through YouTube and lectures that in 20-minute intervals so that you guys can review and use this information wisely. So at the end of these lectures, there will be quizzes. They're only like 6 to 10 questions usually. So if once you get to the end of that, I'll be able to see if you absorb the knowledge or if you need help in any aspect. If you have any questions, you can come to me in class, or you can use Teams as a way to contact me, or even email me. So you have several different ways of getting a hold of me, which I hope you do if you have any questions about any of this information that I am giving you. So let's go ahead and dive into BIOS. First things first, what is the difference between a BIOS on a computer and firmware and any other device? Well, there is no difference. A BIOS is just a fancy name that people, probably in IBM, sat around on a table and first created the firmware for a computer. Basically, the BIOS stands for Basic Input Output System, and it is basically software. It is almost like a pre-operating system, so to speak. It turns everything on and it checks all the components that it's plugged into. So the system BIOS or ROM BIOS which used to be the old term. ROM BIOS stands for read-only memory, and the read-only chips. Right, we now use flash memory, but when people start talking about those little chips, sometimes they refer to them as ROM and sometimes they refer to them as flash. But the new motherboards use flash memory. This flash memory is like the memories you use in a USB stick when you plug it into a computer. The name stuck, and a lot of people interchange those terms. The same way as they interchange BIOS with firmware. Posting. When we talk about posting, we talk about this screen here, as you see in this picture. This BIOS is by American Megatrends. They're one of the leading people that make BIOS for many different manufacturers that create and make motherboards. Now, when the PC turns on and starts, you'll see this screen. It's called a post screen. POST stands for Power On Self-Test. It checks the CPU, the memory, the display, the keyboard, and the mouse. If any of those are not working correctly, it will display down on the bottom of the screen. And if there's a problem with CPU or memory, it won't post. But if someone asks you, did the computer post, this is what we're talking about. And as you can see on the screen here, you can actually see the version, the type, and the memory that's actually on the computer. Now, when we say once the hardware checks out and the computer boots into the operating system, we call that the boot. So you need to know the difference between a post and a boot when you're working on computers, because someone can ask you, did it post? And you say yes, but did it boot? No, that means there's something wrong with the operating system. If it doesn't post, then there's something wrong with the hardware, and you have to go into the BIOS and maybe figure out exactly what's going wrong. It could be, many things. You just have to troubleshoot and figure that part out by going into the BIOS. The BIOS is on the board. All right. Usually you'll see the word CMOS and BIOS near each other, and that's where you can just find that little chip. Where the yellow circle is, that is the actual BIOS on this motherboard here. You can generally look around on the motherboard and you'll be able to find it pretty quick, especially on the newer ones. The BIOS, like I said, is stored in flash memory, and it is the same type memory, like I said before, in flash drives. It can have more than one BIOS on the actual board. Sometimes they use it for backup, just in case if you do a lot of BIOS updates for some reason, it will have a backup BIOS just in case one of them gets bricked and you can't access it. Also, you can have a motherboard. Maybe you might have a reason to be overclocking a lot on one BIOS, and you want to keep another profile on another BIOS. So it just really depends on what you're doing with the motherboard, but you can have more than one BIOS. Generally, I haven't seen a motherboard with more than two BIOS, but that's a whole nother bag. Now, when we talk about legacy BIOS, we want to talk about the older style of the BIOS. It's the original or traditional BIOS. It's more than 25 years old, and the operating system, the operating systems talk to the hardware through the BIOS back then. You still, with the new BIOS, they do talk to the hardware in a sense, but once the operating system takes over with the newer motherboards and systems, the BIOS actually goes to sleep in a sense, and the operating system takes over with accessing the components that are on your motherboard. The problem with legacy BIOS is there is limited hardware support anymore. A lot of the drivers, network cards, video cards, and storage devices have matured enough to where it's outgrown the motherboard. So the manufacturers had to come up with a new way of communicating to these new devices. That's where the UEFI BIOS comes in, the Unified Extensible Firmware Interface. It's based off Intel's EFI, the Extensible Firmware Interface, and it's a defined standard, and it's implemented by the manufacturers. Okay, so all of them share this information and use it pretty much in the same way. This makes it easier for components to hook into their motherboards because everyone is using the same standards and the same settings for whatever components that you're hooking into the motherboard. It was designed to replace the BIOS, a need for modern BIOS for modern computers, and older BIOS could not support newer components. So there was a real need about 12 years ago to move over to the UEFI BIOS. And this BIOS is more robust. It has a graphical and text-based GUI, and you're able to use a mouse and a keyboard to access most of the settings in the menu. It's easier to navigate, and you're able to replace all modern hardware on these motherboards. Why is UEFI better? Well, to start off with, it can boot from a 2.2 terabyte hard drive. Back before UEFI, a legacy motherboard can only handle a 2 terabyte hard drive. And then we're talking about GUID partition table, the GPT disks. The UEFI can communicate with the GUID, but a legacy cannot. So it also supports FAT and removable media, and it can boot from a flash drive. This makes it a lot easier to boot from another operating system and maybe troubleshoot with, you know, some tools that you could use, like a WinPE drive, so you're not actually operating off the damaged hard drive, and you can diagnose that way. It also includes a pre-boot environment, so it's basically a pre-operating system, and it has its own shell, drivers, and applications. You can browse the internet, backup storage, a backup storage drive. You can also remote diagnostics within an operating system. You can actually go online with these new BIOS. So it's really interesting and helpful to have a BIOS that can actually run within itself. We're going to discuss a little bit about non-volatile BIOS memory. It's a mouthful, but it just basically means that your memory needs power hooked up to it in order for it to save changes to your BIOS on your motherboard. Without that power, your everything would be set back to default settings on your motherboard. That means that which drive you boot from, where you find the operating system, all the ports that are configured will go back to the way it was at factory settings. This type of memory needs to retain those settings by using actual power. To power your non-volatile memory, you needed a battery of some sort, and it used to be made out of a metal oxide conductor. It was called the CMOS battery, which means complementary metal oxide semiconductor. It was before flash memory. It was during the ROM memory days, and it constantly refreshed the memory so settings were not lost. However, the name stuck after the use of flash memory, and which basically remained, and the new CMOS battery was still called the CMOS battery, even though it had changed to basically a watch battery. And the only thing that watch battery actually does is hold the date and time for your motherboard. Now, older boards, you can actually reset the BIOS by unplugging this little battery. With the new motherboards, you'll need to use a jumper in order to reset the configurations to default settings, because sometimes someone or something happens to where the BIOS has been configured so wrong that you can't even access it. And if you're to reset everything to the default settings, you're able to reboot and repost actually to the BIOS. Okay, that completes this lecture about the BIOS. The next lecture will be on BIOS options, and at the end of this lecture there is a quiz that you need to take. It's in the module, whatever module you're in. For 000 or 001, there is a link to the address on forms in order to complete this quiz. I'll be able to see your name and who actually took the quiz, and I expect everyone to participate. So please do that for me, and we'll talk a little bit more about the BIOS on Monday. Okay? Have a good day.